Pacemaker batteries. People with an irregular heartbeat can be fitted with a device called a pacemaker. This sends electrical pulses to the heart to make it beat at the correct time. For convenience, the battery is placed inside the patient, so it needs to be small and safe. It also needs a long life, as replacing the battery requires an operation. The first pacemakers used mercury batteries. These only lasted between 1 and 2 years. In the 1970s, atomic batteries were developed for use in pacemakers. These used a tiny sample of uranium-238. This emits alpha particles. These are easily shielded from the user, and uranium-238 has a very long half-life of 4.5 times 10 to the 9 years, making batteries lasting over 30 years a possibility. The alpha particles heat up the sample of uranium, and this then provides the heat source for a device called a thermocouple. Here we have a diagram of a thermocouple. It consists of wires made of different metals. Here we have a thermojunction, which is kept hot within the uranium source, heated by the alpha particles, and another junction which will be kept cold. When the two junctions are at different temperatures, an EMF is produced. Several thermocouples can be linked together to increase the EMF. This makes what is called a thermopile. As the sample decays, the temperature difference will reduce, and so the EMF produced will reduce. If an isotope with a long half-life is used, the battery can last for many years. These devices are called radioisotope thermal electric generators, or RTGs. Currently, pacemakers are fitted with lithium iodide batteries. These rely on chemical reactions. These have a life of around 10 years, and it's felt best to replace the pacemaker after this time with updated technology. Researchers are also working on a pacemaker that can be powered by the movement of the body, meaning they could potentially last as long as the user lived.